Assalamualaikum warahmatullahi wabarakatuh. I am Muhammad Faiz FYP and today I will present my extended proposal defense for my final year project entitled Aqueous Phase Reforming of Sorbitol to Hydrogen and Value Added Chemicals over Nickel Aluminium Catalyst Group 2 Metal Oxides. My project was under supervision by Dr. Muhammad Tazli bin Azizan. So today's presentation, I will start off with the introduction, where I cover the background of study, problem statement, objective and scope of study. And next is the literature review of the whole project. And later we'll follow with the methodology. In methodology, I will explain the research method that we used in this project and the general experiment activity that will be done later. And finally is the project timeline of my study plan. Okay, first of all, let me start with the introduction. This is the summarize of the whole project. We start with the energy issue. The rising of energy demand has caused concern regarding the decrement of fossil fuel reserve and the pollution caused by this. Many research and new alternative ways in finding a more sustainable and eco-friendly way of producing energy has been done, and it is found that biomass has the potential to provide sustainable source of energy for the industry. And under biomass itself, it can be divided into two conversion. First is biochemical conversions, and second is thermochemical conversion. And under thermochemical conversion itself, it can be categorized into three that are gasification, pyrolysis, and reforming. And under reforming is the aqueous phase reforming. And this project will cover about the aqueous phase reforming of sorbitol via group 2 using with the presence of nickel alumina as catalyst, and magnesium will act as the promoter. The catalyst will be first synthesized using the wet impregnation method, then it will be later be characterized using several equipments, and I will explain these equipments in the methodology. And the performance of the catalyst used will be evaluated, and the value added chemical produced and its product distribution will be identified. Next, we move to the background of study. Previous report and studies has shown that the total world consumption of the global market energy keep on expanding from time to time, and oil remain the world's leading fuel, standing at 32.9% of global energy consumption. And people is totally depending on abundant and uninterrupted supply of energy for living and working. Therefore, in 2007 report state that extensive research found that renewable energy not only extends the shelf life of the existing non-renewable fossil fuels, but also to reduce the level of carbon dioxide in the Earth atmosphere. This idea of minimizing the high temperature and energy requirement for process has been found by Dumizy, where he developed a new reforming technology that fit to convert aqueous sugars and polyols such as sorbitol, glycerol, and glucose to hydrogen, and called aqueous phase reforming. Next is the problem statement of this project. In this project, the catalyst will be used as to form the hydrogen from sorbitol in the aqueous phase reforming, and the catalyst used is nickel alumina, which is a cheap and yet found to be effective catalyst, and it is widely used in fuel stem reforming in industrial scale. This catalyst can be improved by small addition of group 2 base metal oxide as promoter. Magnesium as catalyst promoter in this project will correspondingly improve the activity and stability of the catalyst, which is found from the previous research paper, and it is hoped to give the same result. This catalyst will be synthesized first through wet impregnation method, and later this project is mainly done to study the further effect of the catalyst by using magnesium as promoter for the nickel aluminium catalyst in the aqueous phase reforming of sorbitol to produce hydrogen. And the research question for this project is: magnesium is predicted to be able to enhance the nickel aluminium catalyst in terms of dispersion metal and support interaction surface area and prevent catalyst deactivation, and it is hoped to give the same result for the projects. We start with the research objective. First objective of this project is to synthesize and characterize nickel aluminium catalyst promoted by MG for the production of value-added chemicals via aqueous phase reforming of sorbitol. And next is to conduct aqueous phase reforming sorbitol over the synthesized catalyst and identify the value-added chemicals product. So this is the research objective. And moving on to the scope of studies. First of all, I will start the experiment by preparing nickel aluminium catalyst by using wet impregnation method, and magnesium will act as the promoter, and the effect will be studied by characterization of this catalyst by using certain equipment, and we will go through the equipment in the next slides in methodology. And after characterization, the catalyst will undergo catalytic activity test, which will be done by using the Premax autoclave batch reactor. And the product of this test for gas will be tested using the gas chromatography mass spectrometry, GCMS, and for the liquid product it will be tested using the HPLC, high performance liquid chromatography. The performance of catalyst used will be evaluated, and value-added chemical produced and its product distribution will be identified. Only the best catalysts that yield the best value-added chemicals will undergo the process optimization. Moving on to the literature review. First of all, we start with the energy issue. The present global energy system is still dependent and largely based on chemical fuels from fossil fuels. It is shows that oil is still the global leading fuel, and the continuous increment of energy demand and depletion of fossil fuel reverse make hydrogen an alternative source. Hydrogen is currently derived from non-renewable natural gas and petroleum, but also it can be produced from renewable sources such as biomass or water. So, in recent years, many research and studies were done in order to to promote a safer and a cleaner renewable energy source. The statistics in the figure above shows the statistic obtained from World Energy Sources Report in 2016, where it shows that renewable energy and a cleaner energy has started to make a notable process from years to years. This might happen because the biomass gasification offers the most economical route in production of renewable hydrogen, and plus many industries have started to promote a safer and a cleaner renewable energy sources. And next, moving to the hydrogen technology. To accommodate the current global energy demand and reduce greenhouse gases emission, biomass is selected as a potential feedstock for hydrogen production. Starting with biomass source, biomass is abundant and also renewable in nature. Hydrogen can be produced from biomass, and it is found that hydrogen energy system has the potential to be a viable, sustainable source of energy in meeting the global energy requirement. Plus, biomass recently is the fourth largest energy in the world, which is 50% of the world's primary energy consumption, and about 38% of the primary energy consumption in the developing countries. In general, biomass is commonly converted using two main technologies named biochemical conversion and thermochemical conversion. In biochemical conversion, biomass is converted to produce precursor chemicals such as ethanol and other alcohols through a biochemical method. For example, enzymatic decomposition. And under the thermal conversion, it does give a simpler route for biofuel production. Thermochemical conversion plus not require any chemical addition and able to completely utilize the entire feedstock, and the time taken to complete the conversion is also shorter. Under the thermochemical conversion, there are gasification, pyrolysis, and reforming, which under reforming is stated the aqueous reforming process. Moving on next to the aqueous phase reforming. Aqueous phase reforming was first founded by Dumisic and his co-workers in 2002. APR was developed with significant advantage include this is the technique that contain non-flammable and non-toxic oxygenated compound of interest, so it is easier to be stored and handled safely. Besides, the effect of aqueous phase reforming to greenhouse gas emission is zero, making it completely environmentally friendly process for producing hydrogen. Next is the equation for the APR process. The reaction of aqueous phase reforming in the feed alkene will produce hydrogen and carbon monoxide, and onwards the carbon monoxide will react in the excess water through the water gas shift to produce carbon dioxide and more hydrogen. This is the equation transformation of alkene into hydrogen and carbon monoxide, and this is the equation of water gas shift reaction. Moving on next to the sorbitol. Sorbitol, or also known as D-glucitol, is a sugar alcohol and have a sweet taste and mostly made up by corn syrup. It is a non-carcinogenic and reduced calorie value and a very low glycemic index, and usually was manufactured in industrial by catalytic hydrogenation of sugar, starch or glucose syrup at high temperature. Here is the process of producing sorbitol by dehydrogenation of hydroxyl group. And next is the aqueous phase reforming of sorbitol, where it shows that it gives out hydrogen and carbon dioxide as the product. In the aqueous phase reforming of sorbitol, catalysts present will have certain problems, including it is easily deactivates under aqueous phase reforming condition through oxidation metal, centering carbon deposit on particles or metal leaching. Therefore, nickel catalyst will be present with the addition of alumina as the support, and catalyst promoter is also added to overcome the problem. In this project, magnesium will be chosen as the catalyst promoter. The catalyst will be first passed through synthesizing process. Wet impregnation method will be used in this project, and it is expected that the catalyst synthesized in this experiment will give a good hydrogen selectivity at the end. Here is a sample of the previous researches and study that were done by aqueous phase reforming of sorbitol, but using different type of catalyst. And it can be seen that the Hauber et al. In 2004 has shown the presence of platinum and aluminium oxide as catalyst has given 60% H2 selectivity compared to others. Next is the research methodology that being used in this project. First, the project started with the identifying of the background study of the project and to get the objective, the whole idea of the project. Then proceed with the understanding the problem statement in order to highlight the issue. Thus, the objective can be identified in order to set the research parameter for the project. The collection of data and finding is done for the literature review. The data obtained for various articles, related research paper, journal and book regarding the study is evaluated and compared with other resources. This is to ensure that an updated and current results are obtained. This research process continue with the methodology to get the methods, equipment and material methods for the project. Finally, the findings are documented and reported in detail. Next is the general project experiment activity. First, I will start with the catalyst preparation, wet impregnation, catalyst characterization, catalyst activity test and product identifying like the previous earlier steps. In catalyst preparation, the catalyst will be prepared using wet impregnation method by mixing nickel nitrate, dihydrate and gamma alumina in aqueous solution with the ionized water. The table shows the sample composition for wet impregnation. The solution is mixed and stirred at 400 rpm for 4 hours and filtered to remove excess liquid and left that overnight in oven and will be later crushed using mortar and calcined in furnace for 16 hours. Next, the synthesized catalyst will later undergo catalyst characterization to study the properties, and this equipment will be used depending on the period of time before or after calcination. Next is the catalyst activity test, which will be done in the premix autoclave batch reactor with a capacity of 250 ml. Below are the parameters of the premix autoclave reactor. And after the catalyst activity test, the resulting liquid and gas product will be collected using vials for liquid and gas bags for gases, and it will be tested using analytical equipment to determine and identify the yield of hydrogen and value-added chemicals produced. Analysis of product will be used gas chromatography mass spectrometer for gas and high performance liquid chromatography for liquid products. This is the list of labwares and apparatus that will be used in this project, and this is my study, and that's all from me. Thank you.